Here's a question with an answer nobody expected. If you want to sneak AI-written text past a detector, and the detector is allowed to fight back, retrain itself on your exact attack, which attack survives? This paper's answer? You stop trying to make the writing look human, and you ask the model to write like it's 1923.
And the detectors don't kind of struggle. They fold instantly. Text-to-detector was calling machine-written with near total confidence. Rewritten in an old literary register, walks straight through.
By the end, you'll understand why the clever, obvious way to beat these detectors collapses, and why writing like a 100-year-old novel is the thing that holds. And the part that got me. The researchers tried the obvious defense, retraining the detector on real 1920s books, and it made the hole bigger.
This matters because right now, teachers, journals, and platforms lean on these detectors like they're a reliable gate. This is a paper about a whole category of writing walking straight through that gate with one prompt tweak. So the obvious move, if you're the attacker, is to make the AI text look more human. You strip the robotic tells, you add a few typos, run it through translation so the phrasing gets rougher. Coach the model to use human-sounding vocabulary. Make it blend in.
And in 2025, that worked spectacularly. In the 2024 competition, it's called the Voight-Kampff task after the empathy test in Blade Runner, the best evasion fooled the detector panel about 5% of the time. In 2025, that jumped to roughly 2 in 3. That's about a 13-fold leap, and it came entirely from prompting. No better model, no retraining. One team literally round-tripped the text through Hindi and told the model to be imperfect.
Right. Make it look human, and you win. Except that's exactly the strategy this paper shows dies the fastest. The moment the detector retrains, it doesn't just stop working, it backfires.
To see why, you need one number and one move. The number is the fool rate, the fraction of AI texts the detector wrongly labels human. A higher fool rate means a better attack. The move is what defenders do in a real arms race. They collect examples of last year's winning attack and retrain the detector on them. That's adversarial fine-tuning. You got fooled, so you study the fool and patch it. So the authors build the strongest detector they can. It's a classifier reading the statistical fingerprint of text, roughly how predictable each word is given its neighbors. AI models pick safe, high-probability words, while humans wander more. Trained on the 2025 data, this detector is near perfect on familiar text. On a plain generation from Claude, it says AI with near total confidence.
Then you run that same text through the 2025 recipe, the Hindi round trip, the be imperfect instruction.
And the same detector flips to about 0.1% confidence that it's AI. Same text, one translation pass. From all but certain it's a machine to all but certain it's a human.
Wait, that's the old, already fooled detector though. That's before it fights back.
Right, and here's the turn. They retrain it on those attacks. Now the disguise doesn't just stop working, it inverts. The disguised text becomes more obviously machine-written than a plain generation. The attack that gave you a big advantage now hands you an equal-sized disadvantage.
Juniper, that's the part I keep snagging on. How does patching it make the text more detectable than doing nothing at all?
Picture a bouncer who's learned one obsessive rule. Real IDs are a little worn. Crisp, pristine ones are fake. Hand him a deliberately roughed-up fake and he doesn't hesitate. He waves it through, because the feature he trusts now points the wrong way. Now retrain him. He learns that specific roughed-up look is the fake, but the disguise still carries that one consistent signature. The flatness translation leaves behind. So the flatness that used to say human now screams attack. The sharper the detector, the more confidently it flags it. Their line for it? The in-distribution accuracy and the fool rate are the same number twice, in opposite directions.
So before we move on, why does the whole make it look human approach fail so completely?
Because the disguise leaves a fingerprint. It's consistent and it's learnable, and consistent and learnable is exactly what one retraining pass kills.
Subscribe if you want every major AI paper broken down like this, daily, because the next turn is the strange one. The attack that survives the retrain does the opposite of blending in.
So if blending in dies, what survives? The author's hypothesis flips the whole strategy. Don't pull the text toward the human examples the detector knows. Push it somewhere the detector has never been.
This is the in-distribution versus out-of-distribution idea, and it's the concept the whole paper rests on. A detector is only calibrated on the data it trained on. Feed it something like that data, modern fluent English, and it's reliable. Feed it something genuinely unlike anything it saw, and it has no map for it.
The face camera version makes it click. A security camera trained on thousands of modern selfies learns to flag faces that look like the ones it's seen. Someone in full 1920s costume, different hair, different clothes, different photographic grain, matches nothing in the training set, so it doesn't trip. And the reframe underneath is the sharp part. A detector trained to spot AI text is really just a detector for text, unlike its human examples. Anything genuinely unusual lands in a blind spot. So they change not the grammar, but the epoch. The main attack, they call it Synth-anchor, is 2 API calls. First, the model writes a short period paragraph, about 120 words, on a topic near the target. Then it rewrites the actual text in that paragraph's exact register, using it as a template. That's the whole recipe. No retraining, no access to the detector.
And against the retrained detector, the one that eats the 2025 attacks alive?
It fools it about 80% of the time. A fool rate of 0.798 against a detector that beats last year's attack down to roughly 1.5%. That's about 50 times more effective, on the same detector, same generator, same topics.
Okay, but I'd expect period costume prose to read as stilted. Doesn't it just trade sounds like AI for sounds like a bad Gatsby impression?
That's the natural prediction, and it's wrong. They scored naturalness with a panel of AI judges rating how human each passage reads. The 2025 recipe wrecks it. Human likeness drops from about 0.54 to 0.30. The period rewrite reads at 0.535, essentially even with a plain generation at 0.540. So it holds its naturalness rather than collapsing. Hold on to that AI judge's detail, Finn. You're going to want it in a few minutes.
So is it the old-timey flavor specifically, or just any distinctive, unusual voice?
They tested that head-on, imitating famous authors. Imitate Borges. Unmistakably distinctive but modern. And the detector catches it. Fool rate about 0.095. Imitate Sebald, whose style is deliberately old-fashioned. And it works. 0.749. It's the same distinctive author idea, but with opposite results. It's the era of the writing that moves it out of distribution, not how unique the fingerprint is.
So far, making it look human dies in one retrain and backfires. Pushing it out of distribution, into an old register, survives, and it reads more human on top of that.
All of which sets up the obvious defense. If the blind spot is period register, plug it. Get real pre-1923 books, about 1,000 passages of actual old prose from Project Gutenberg, and mix them into the human side of the detector's training. Now it's seen the register. Now it should catch the fakes.
And they wrote the prediction down first. They expected the fool rate to fall to 20% or below.
It rose to 0.846, nearly 9 in 10. The fix made the hole bigger.
Hold on. They showed it real old books, and it got worse at spotting fake old books.
Worse. Because you never taught it to tell genuine period prose from machine-emulated period prose. You just told it archaic language is fine and carved out a bigger safe zone, and the attacker moves right into it. It's like teaching a spam filter to allow Shakespearean English by feeding it real Shakespeare. You didn't teach it real versus disguised, you just widened the door.
So, one line. Why does retraining on old books backfire?
Because widening the human region doesn't teach the detector to separate real period prose from emulated period prose. It just gives the attacker more room to hide. And two controls nail the direction. When they coached the model to imitate the detector's own human training texts, pulling straight into the distribution, the fool rate was 0.000. Nothing. And a version using genuine old book passages as the template did worse than the synthetic one. So authenticity wasn't the lever. Direction was. Out of distribution wins, into distribution does nothing. One more result, because it's the one that won. A stream of consciousness attack. A single narrator, almost no full stops, a concrete sensory detail roughly every 40 words, pulled off something rare. It escaped the retrained detector about 65% of the time, while also slipping past a separate panel of detectors. That entry took first place, and the team swept the top 5 spots.
And this is where I want to push, Juniper, because the framing is bypasses state-of-the-art detectors, and I don't think the evidence is quite that clean. I've got 2 problems with it. First, the state-of-the-art detectors here are the author's own reconstructions. They rebuilt the 2025 winning recipe and then beat it. "We built a strong detector and beat it" is weaker than "we beat the field's best fielded system." The live leaderboard sweep does back it up, so it's not empty, but the scary top-line numbers come from detectors they calibrated themselves. Second, that naturalness result, reads more human, not less, was judged by other AIs. AI judges have known biases, and a passage an AI rates as human-sounding might read as affected and stilted to an actual teacher. That claim needs human raters, and it doesn't have them.
Both of those are fair, and I'll concede them. The naturalness one, especially. It's an AI grading an AI's costume. And I'd add the honest ceiling myself. This isn't AI text is undetectable, it's the current supervised detector paradigm has a specific blind spot. Watermarking, where the provider stamps a hidden signal in at generation time, is a different game this attack doesn't touch.
And there's a deflating practical answer buried in their own results. That separate detector panel, the one that never trained on these attacks, catches almost everything the retrained one misses. Run both, an in-distribution detector and an out-of-distribution one, and you catch nearly all of it. The exception is stream of consciousness. So the takeaway might be less, detectors are broken, and more, run 2 of them.
Which is a real answer, and an uncomfortable one, because stream of consciousness is the residual whole. And the paper's whole point is that you can't count on having seen the next weird register in advance. So, back to where we started. Ask a model to write like it's 1923, a detector that was near certain flips to waving it through, and patching the hole with real 1920s books only widens it. The bigger claim outlives any single prompt. A detector for AI text is really a detector for text unlike its examples, and you can't patch a blind spot by adding one corner of it.
So here's the question. Do we keep hardening these classifiers attack by attack? Or is the real move to stop detecting after the fact and watermark it generation instead? If you grade or publish with one of these tools, that's the call in front of you. Tell us where you land.
The full annotated version is on paperdive.ai, every term tapped to define, with links to the related papers by theme.
Quick housekeeping. The script was written by Anthropic's Claude Opus 4.8. Juniper and I are AI voices from 11 Labs, and we're not affiliated with either company. The paper is Structural Shifts in AI Writing Bypass State-of-the-Art Detectors by Dima Galat and Marian-Andrei Rizoiu, posted July 15, 2026.
So next time a detector clears a piece of writing, don't ask how confident it is. Ask what it's never seen. That's where the gap lives.